Space has always captivated humanity. Planets, stars, and galaxies beckon us to explore the unknown. Among these celestial wonders are moons, natural satellites that orbit planets. Our solar system is teeming with these fascinating objects, each with its own story to tell. Some are large and active, while others are small and icy. They range from small rocky bodies to large icy worlds with subsurface oceans. Understanding these diverse objects is crucial to unraveling the history and evolution of our solar system. The study of moons offers valuable insights into the formation and evolution of planetary systems. Neptune, the eighth and farthest known planet from the Sun, is a gas giant with a system of rings and 14 known moons. This distant realm is home to a collection of intriguing moons, each with its own story to tell. Neptune itself is a fascinating world, with its swirling blue atmosphere and powerful storms. Among these moons is a small, icy world named Neso, notable for its extreme distance from Neptune. Neso is a testament to the incredible diversity of our solar system. Its peculiar orbit and distant location make it a challenging target for observation. Neso, Neptune's moon, is a small, icy world that orbits the planet at an incredible distance. It stands out even among Neptune's moons for its unusual characteristics. Join us as we unravel the secrets of Neso, a small moon with a big story to tell. From its discovery to its unique features, we will explore what makes Neso a captivating object of study. Get ready to discover the wonders of Neso, Neptune's mysterious moon. The team conducted follow-up observations using some of the world's most powerful telescopes. The data they collected confirmed their initial hypothesis. The object was indeed a moon orbiting Neptune. The discovery was announced in 2003, sending ripples of excitement through the astronomical community. Neso's orbit around Neptune is highly eccentric, meaning it is stretched out into a long ellipse. It takes a staggering 26.6 years for Neso to complete one orbit around its parent planet. This long orbital period is a consequence of Neso's extreme distance from Neptune. The discovery of Neso highlighted the importance of international collaboration in astronomy. The team that discovered Neso comprised astronomers from different institutions and countries, all working together towards a common goal. Sharing data, resources, and expertise allows astronomers to make discoveries that would be impossible for any one individual or institution to achieve alone. The discovery of Neso was not merely a matter of pointing a telescope at the right spot at the right time. It required meticulous planning, sophisticated technology, and the combined expertise of astronomers from around the world. Following its discovery, the Moon was given the temporary designation S2002N4. The discovery team proposed a more permanent name, Neso, after one of the Nereids in Greek mythology. The Nereids were sea nymphs, daughters of Nereus and Doris, known for their beauty and association with the sea. The name Neso was deemed fitting for Neptune's moon, given the Roman god Neptune's association with the sea. The International Astronomical Union officially approved the name Neso in 2007. Neso, even amongst Neptune's distant moons, stands out for its exceptional faintness. Its small size and immense distance from the Sun render it exceptionally difficult to observe from Earth. The sunlight that reaches Neso is extremely weak, having traveled billions of kilometers across the solar system. As a result, Neso's surface is incredibly cold, with temperatures estimated to be well below freezing. Despite these challenges, scientists have been able to glean some valuable insights into the nature of this distant world. Based on its observed brightness and estimated reflectivity, astronomers believe that Neso is a relatively small moon, with a diameter estimated to be around 60 kilometers. Its small size contributes to its faintness, making it a challenging target for observation. The exact shape of Neso is unknown, as its faintness makes it difficult to resolve its shape with current telescopes. However, astronomers believe that it is likely irregular in shape, similar to many other small moons in the outer solar system. By studying small moons like Neso, astronomers can gain a better understanding of the distribution of matter and the dynamics of planetary systems. Although its composition has not been directly measured, Neso is thought to be primarily composed of ice, similar to other small outer solar system moons. The ice on Neso is likely a mixture of water ice, along with frozen gases such as methane, ammonia, and carbon dioxide. The presence of these volatile compounds suggests that Neso may have formed in the outer regions of the solar system. Over time, gravitational interactions with other bodies may have scattered Neso into its current distant orbit around Neptune. This possibility, while speculative, adds another layer of intrigue to this distant world. Neso's surface features remain largely unknown due to its extreme distance and faintness. Current telescopes lack the resolution to discern any surface details. It is likely that Neso's surface is heavily cratered, bearing the scars of billions of years of impacts. The lack of a substantial atmosphere means that even small impactors can create craters on Neso's surface. The exact nature of these features, however, remains a mystery, waiting to be unveiled by future missions. Neso's orbit around Neptune is a testament to the complex gravitational interactions that shape our solar system. Unlike the nearly circular orbits of planets like Earth, Neso's path is highly eccentric, resembling an elongated ellipse. This means that Neso's distance from Neptune varies significantly throughout its orbit. At its closest point, Neso ventures relatively close to Neptune, at a distance of roughly 48 million kilometers. However, as it swings around to its farthest point, Neso journeys to an astounding 74 million kilometers from its host planet. Neso's orbit is not only eccentric but also highly inclined relative to Neptune's equatorial plane. This inclination means that Neso's orbital path takes it significantly above and below the plane in which most of Neptune's other moons reside. The combination of Neso's high eccentricity and inclination results in a complex and fascinating dance around Neptune. As Neso travels along its elongated path, it weaves above and below the orbits of Neptune's other moons. These gravitational nudges can have a cumulative effect, causing Neso's orbit to slowly evolve over millions of years. Neso is not alone in its distant and eccentric orbit around Neptune. It is a member of a small group of Neptunian moons known as the Irregular satellites. These moons are characterized by their large distances from Neptune, their high orbital eccentricities, and their often retrograde orbits. The other irregular satellites of Neptune share similar orbital characteristics with Neso, suggesting a common origin or capture mechanism. The study of Neptune's irregular satellites provides valuable insights into the dynamics of planetary systems. Despite its chaotic origins and seemingly precarious orbit, Neso's path around Neptune is surprisingly stable over astronomical timescales. While gravitational interactions with other moons can slightly perturb its orbit, Neso is not in danger of escaping Neptune's gravitational grasp. Neso's orbital stability is due in part to its large distance from Neptune and the relatively weak gravitational influence of Neptune's other moons. Furthermore, Neso's orbit is in a state of resonance with Neptune's other irregular satellites. This resonance helps to stabilize their orbits over long periods. Neso, despite its diminutive size and remote location, holds a significant place in our understanding of Neptune's moon system. Its unusual orbit and likely captured origin make it a valuable witness to the dynamical processes that have shaped the system over billions of years. Like a distant sentinel, Neso has silently observed the evolution of Neptune and its retinue of moons. The very existence of Neso in its current orbit challenges our understanding of moon formation. Neso's capture event likely left its mark on the orbits of other Neptunian moons, providing astronomers with a glimpse into the chaotic early history of the system. The study of Neso's orbit can provide valuable insights into the history of Neptune's gravitational influence. By carefully analyzing the moon's current orbital parameters, astronomers can work in reverse, like celestial detectives, to reconstruct the events that led to its capture and subsequent orbital evolution. For instance, the degree of Neso's orbital inclination relative to Neptune's equatorial plane can provide clues about the direction from which it was captured. A high inclination suggests a capture from a highly inclined orbit, perhaps originating from the scattered disk, a region of the outer solar system even more distant and dynamically active than the Kuiper belt. Furthermore, numerical simulations of Neso's orbital evolution, taking into account the gravitational influence of Neptune's other moons, can help astronomers constrain the timing of its capture. These simulations can reveal whether Neso was captured early in the solar system's history or more recently, providing a timeline for the evolution of Neptune's moon system. Neso's significance extends beyond its individual story, as it serves as a representative of a broader class of objects known as irregular satellites. These moons, characterized by their distant, eccentric, and often retrograde orbits, are thought to be captured objects, remnants of the early solar system's chaotic planet formation process. By studying Neso and other irregular satellites around Neptune and other giant planets, astronomers can gain a better understanding of the processes that shape the outer solar system. These moons offer a window into the dynamics of planetary capture, the distribution of icy material in the early solar system, and the complex gravitational interplay between planets and their captured companions. The diversity of irregular satellites, in terms of their sizes, colors, and compositions, suggests that they originated from different parts of the early solar system, each carrying a unique record of the conditions in their formation regions. Neso, with its extreme distance and likely Kuiper belt origin, represents a particularly intriguing piece of this celestial puzzle. While our understanding of Neso is limited, future missions with advanced telescopes could unlock its secrets. A dedicated mission to Neptune could provide high-resolution images and reveal geological features. Spectroscopic observations could confirm its icy nature and search for organic molecules. Exploring Neso would enhance our understanding of the outer solar system. Neso's orbit stands out even among the irregular satellites of Neptune. It is one of the most distant moons in our solar system, with an average distance from Neptune exceeding 48 million kilometers. To put this in perspective, if Neso were to orbit Earth at this distance, it would lie far beyond our moon, nearly a third of the way to the Sun. This extreme distance translates to an incredibly long orbital period. Neso takes a staggering 26.6 Earth years to complete one full orbit around Neptune. Imagine the cosmic patience required for Neso to trace its elongated path through the frigid depths of the outer solar system, witnessing just one Neptunian year for every 26.6 Earth years. This extreme orbital dance is a testament to the enduring grip of gravity, even at such vast distances. Neso's orbit is a delicate balance between the gravitational pull of Neptune and the subtle influences of other celestial bodies, a cosmic choreography that has played out over billions of years. Neso's unusual orbit is a record of ancient gravitational interactions. Its eccentricity and inclination suggest close encounters with other celestial bodies. Neso's capture likely involved gravitational tugs from Neptune and other objects. It may have originated in the Kuiper belt. A chance encounter could have perturbed Neso's orbit. Another scenario involves Neptune's early migration. Neptune's movement could have scattered and captured objects like Neso. Neso's extreme distance and faintness make it a challenging target for observation, but they also hold the allure of unexpected discoveries. As telescopes become more powerful and future missions venture farther into the outer solar system, we can expect to learn more about this enigmatic moon and its unique characteristics. One area of interest is Neso's surface composition. Based on its location and presumed origin in the Kuiper belt, Neso is thought to be primarily composed of water ice, along with frozen volatiles like methane, ammonia, and carbon dioxide. However, the exact proportions of these materials and the presence of any other compounds remain unknown. Future observations using more sensitive spectrographs could reveal the detailed composition of Neso's surface, providing insights into the conditions in the early solar system and the processes that shaped the outer planets and their moons. Discovering unexpected materials such as organic molecules or minerals altered by water ice would further pique our curiosity about this distant world. Beyond its individual characteristics, Neso's significance lies in its potential to provide insights into the chaotic early history of our solar system. The capture of irregular satellites like Neso is thought to be a common occurrence during the early stages of planetary system formation, when the gravitational landscape was in constant flux. By studying the orbits, compositions, and surface properties of these captured objects, astronomers can piece together a more complete picture of the early solar system's dynamical environment. Neso's extreme orbit, likely shaped by multiple gravitational interactions, offers a particularly valuable window into this chaotic period. Through future observations and modeling efforts, Neso's story will continue to unfold, providing valuable clues about the formation and evolution of our solar system and the intricate gravitational dance of celestial objects in the vast expanse of space. Each new piece of information we gather about Neso brings us one step closer to understanding the complex history of our cosmic neighborhood. Neso, the small and icy moon dancing around Neptune, may seem like a world apart, lost in the vastness of our solar system. Yet its story is intricately intertwined with our own. Neso's peculiar orbit and likely origin in the Kuiper belt provide insights into our cosmic neighborhood. Though billions of kilometers separate us, we are bound to Neso by gravity, the same force that holds our solar system together. The study of Neso's orbit and its relationship to Neptune helps us piece together our solar system's history, tracing back to a time when planets migrated and icy remnants were scattered and captured. Neso's story reminds us that even the most seemingly insignificant objects can hold profound secrets, waiting to be unlocked by our curiosity and technological prowess. As we delve into the mysteries of Neso, we confront our own ignorance. Each answer generates more questions, pushing our understanding further. What is Neso's surface composition? Could it harbor surprises? The allure of the unknown drives us to explore and seek answers. Neso, a small moon, reminds us profound discoveries lie hidden. While our understanding of Neso is limited by its distance and faintness, future telescopes will reveal its secrets. Spectroscopic observations will uncover its composition, revealing ices, minerals, and organic molecules. A dedicated mission could study Neso up close, revolutionizing our understanding of this distant world. The story of Neso is just one small chapter in the grand narrative of the cosmos. A story that began billions of years ago with the Big Bang and continues to unfold today. As we explore our solar system and beyond, We are constantly reminded of the vastness of the universe and the countless mysteries it holds. Every new discovery opens up new avenues of inquiry, pushing the boundaries of human knowledge further into the unknown. The universe is a vast and wondrous place, filled with celestial wonders that continue to amaze and inspire us. From the smallest moons to the largest galaxies, each object in the cosmos has a story to tell. A story that speaks to the fundamental laws of physics, the intricate dance of gravity, and the endless possibilities of the universe. As we continue our exploration of the cosmos, we do so with a sense of wonder and humility, knowing that we are merely scratching the surface of what there is to know. The universe is a vast and mysterious place, and we are fortunate to be alive at a time when we have the tools and the technology to explore its wonders. The journey of discovery is ongoing, and Neso, the distant moon dancing around Neptune, serves as a reminder that the most profound discoveries are often those we least expect.